Ever wondered how disk management in Linux works? It's the process of overseeing storage devices, partitions, and file systems, ensuring optimal performance. Key aspects include partitioning, where tools like fdisk and gdisk come into play, file system creation, where utilities like MKFs, ext4 are used, mounting and auto-mounting, vital for managing file systems, disk encryption for data security, RAID configuration for data redundancy, LVM for managing logical volumes, monitoring and diagnostics for maintaining disk health, backup and recovery for data protection, and quotas to limit disk space usage. Now let's dive deeper into these aspects. Firstly, we have disk partitioning. This is where the magic begins. We're going to use tools like fdisk, parted, or gdisk to partition our storage devices, creating primary, extended, or logical partitions depending on our needs. It's like organizing a large warehouse into smaller, more manageable sections. But we need to understand partition table formats such as master boot record and GUID partition table. These are like the blueprints of our warehouse, dictating how we can divide and use the space. Now let's move on to file system creation. Think of this as painting the walls of our warehouse sections. We're going to format our partitions with appropriate file systems using utilities like MKFs, ext4, MKFs, DOCSFs, or MKFs, DTRFs. When choosing a file system, we need to consider factors like performance, reliability, and features. It's like picking the right color and type of paint for each section of our warehouse. That covers the basics of partitioning and file system creation. Moving on, let's talk about mounting and unmounting. In Linux, file systems are mounted to directory paths in the file system hierarchy using the mount command. The mount command is versatile with options such as read-write permissions, specifying the file system type, and selecting the mount point. Now, when these file systems are no longer needed or before performing disk maintenance tasks, we use the umount command to safely unmount them. It's like giving your system a heads up not to write any more data to that file system. Now on to auto-mounting. This is where Linux shines. Tools like autoffs or additions to the /etc/fstab file can be used to configure auto-mounting. This ensures that file systems are automatically mounted when accessed and unmounted when idle, saving resources and making your life a lot easier. That's how Linux handles mounting and unmounting. Next up, we have disk encryption, RAID configuration, and LVM. Disk encryption is an essential tool for protecting sensitive data. Using solutions like LUKS, which stands for Linux Unified Key Setup or dmcrypt, you can encrypt disk partitions or entire file systems. This adds an extra layer of security, safeguarding your data at rest. To set up these encrypted volumes and manage encryption keys, utilities like cryptsetup come in handy. Moving on to RAID configuration, which stands for Redundant Array of Independent Disks. This is used for data redundancy and performance improvement. You can configure RAID using software like MDADM or hardware RAID controllers. The choice of RAID levels such as RAID 0, RAID 1, RAID 5, or RAID 10 depends on your requirements for performance, fault tolerance, and storage efficiency. Finally, we have LVM or Logical Volume Management. This allows for dynamic management of logical volumes, volume groups, and physical volumes, providing flexibility in resizing volumes, adding or removing disks, and taking snapshots. These are some advanced aspects of disk management in Linux. Finally, let's discuss monitoring, diagnostics, backup, recovery, and quotas. Monitoring your disk's health and performance is crucial. By using tools like smartctl, you can check smart attributes and predict potential disk failures. But it's not just about health, it's also about performance. Disk benchmarking tools such as HDParm or FIO can help you measure disk performance and identify any bottlenecks that might be slowing things down. Now let's talk about backups. Backups are your safety net against disk failures, corruption, or accidental deletion. Tools like rsync and tar are perfect for this job. For full system backups and disaster recovery, you can use utilities like DD to create disk images. Lastly, let's touch on disk quotas. Disk quotas are a way to limit the amount of disk space that users or groups can consume on a file system. By configuring disk quotas, you can prevent users from exhausting all the available disk space. Remember, monitoring and diagnostics help you maintain disk health and performance. Regular backups ensure data safety, and disk quotas keep your storage usage in check. And that's a wrap on disk management in Linux. Remember, effective disk management is key to ensuring optimal performance and utilization of your Linux system.